MDM4U 3.3 Nonlinear Regression. Many relationships between two variables follow patterns that are not linear. So we've previously calculated by hand the line of best fit as well as the correlation coefficient. But not all scatter plots will have a linear relationship as a trend between the data. So for example, if you look at the points in the scatter plot, a curve will be closer to the majority of the data, making it a better model to represent this data. Nonlinear regression is an analytic technique for finding a curve of best fit or data from such relationships. Technology is used to determine the best fit curve for data that is entered as well as calculate the coefficient of determination R squared. So we're going to be using a program, it's spreadsheet software called Microsoft Excel, and this will be a great tool for statistical studies and understanding in the future, and it is available to public board students. So make sure that you not only use the online version, but please make sure that you download the Office before you move on to university while it's still available for free. Coefficient of determination. Recall the correlation coefficient R was used to describe how closely a straight line fits the data. The coefficient of determination R squared is defined such that it applies to any type of regression curve. So it's the strength of the model to fit the data. Not the strength of the relationship between X and Y, but the strength of the model to be able to fit that trend line. It's defined as R squared. Variation in Y explained by variation in X divided by total variation in Y. My much preferred definition, the sum of Y estimate, sometimes referred to as Y bar. So Y estimate refers to what would the value of Y be on the curve that we are using to model the data. So for example, if this is the point XY which came from the set, our curve would have predicted that the height of Y for that value of X was going to be here because it's on the curve. So we would need to do that for each and every single point, divided by, minus Y bar. Y bar is the average of Y. Notice that half the points are above, half the points are below. If we were to add all of the Y values together and divide by the total number of points, we would get what Y bar is equal to. Now, the total variation in Y, the sum of Y minus Y bar. So that's for each and every single point, you have your value of Y, whatever height it is, minus Y bar, the average of Y. And our values for the coefficient of determination will be between 0 and 1. Now, this is something that would be very time consuming to do by hand. We have built-in functions into many of our different types of technology that can do this for us, and we're going to investigate that now. But just keep in mind that there are linear regression models, quadratic, polynomial, power, and exponential models. We aren't limited to what our model formula might look like, but if you graph a scatter plot, you can visually see the type of relationship that's trending. So that being said, we're going to look into Microsoft Excel. So I've pre-populated this with some data, but tried to do as minimal changes as possible. So some things we can do, if you click and drag over an area, you can format it using many of the same formatting tools as Microsoft Word. If you want to make a border, you can use this feature here. If you want to click, drag over, shade, just kidding, that was the text. How about we shade it? There we go. And we have our table. If we click and drag over the area with the data, what we can do is insert. One second, let's get the menu in here. Insert, and because we have two variable data, That's illustrated by a scatter plot. Click on this graph and it's already made for you. So no more doing it by hand. This is far more presentable. We can change the title. In general, graphs are Y versus X. Here's the magic. Click on the actual data points. Right click and add trend line. Now in this case here, this does appear to be linear. This isn't starting to curve away from this line. So we'll assume that this is the best fit. Let's just do one thing here. There are the different options of curves that are available. This one right here, I'm assuming is linear as the best fit, and we're going to go through with a line of best fit. Looking at the bottom of this menu, you have two options. Display equation on the chart, so that is the line of best fit. Typically that doesn't change and I still have access to those options. One moment, there we go. Clicking on the line of best fit, sure. Display R² value on the chart. So this calculation can already be done for you in an instance, so we're going to just use the results of it in order to calculate it. We're going to use just the built-in functions in order to be able to calculate this. Next, let's take a look at another option. So if we were to highlight this data, insert, select the graph type that we would like, a scatter plot, and this one here, it's increasing. It looks like it has a horizontal asymptote, so which type of graph would you suspect? It looks like it is exponential. Now, you could compare by doing both the coefficient of determination for a quadratic regression model as well as contrast that with an exponential model, but let's just go with one. So all right, so you click on the data values or points on the scatter plot, right click, and go to add trend line. Now this doesn't really seem to be matching our data, or a different regression model is required. So let's look at our options. Some trend lines cannot be calculated from data containing negative or zero values. So let's try this again. Let's go with exponential, the one I intended to choose. So this does seem to be fitting this data very well. How well can be explained by the coefficient of determination. So remember that this is an exponential function. E is approximately 2.718. It's a constant. And this is the equation of the regression model, the exponential regression model. And R² shows a value of 0.9635, a very strong value. All right, so try some of these questions on your own. If you're having trouble downloading Microsoft Excel, please message me. Thank you.